So I always like to introduce my talks with a song, just to wake all of you up. You say that Rust is like a religion. The community is toxic, and you'd rather stay apart. You say that C can be coded safely, that it is just a skill issue. Still, I know you just don't care. And I say, what about memory and safety? You say, I think I read something about it, and I recall, I think that hackers quite like it. And I say, well, that's one thing you got in C. You are tasked with managing memory with no help from the compiler. There's so much that can go wrong. So what now? The hackers are all over. The system's running over with CVEs galore. And I say, what about memory and safety? You say, I think I read something about it, and I recall, I think that hackers quite like it. And I say, well, that's one thing you got. You say that Rust is a woke mind virus. Rustations are all queer furries, and you'd rather stay apart. You say that C can be coded safely, that you just have to get good. Still, I know you just don't care. And I say, what about memory and safety? You said, I think I read something about it, and I recall, I think that hackers quite like it. And I said, well, that's one thing you got. And I say, what about memory and safety? You said, I think I read something about it, and I recall, I think that hackers quite like it. And I say, well, that's one thing you got. And now, let's jump right in. So first, I want to exhort you to try the beta version, the beta channel. So you get, compared to the stable channel, you get 6 weeks of perf improvements. And the beta, despite its name, has a quite good stability track record. There have been 35 point releases. There has been one more since I wrote that slide. But those usually have errors that you probably won't trip up. If so, and you encounter a bug, you can even help the ecosystem if you use beta version. So it's a win-win all along. And unlike nightly, you don't need to recompile your code daily if you try to keep up to date. So I've looked into the point releases just to see if there's something that you can do to reduce the churn if you have point releases. And as you can see, the median point release arrived about 15 days after the original release. So if you wait a bit more than 2 weeks, then you can even have at least half of them. I guess that's a pretty good track record. And so again, try the beta channel. It's underused at the moment. And also note that if there is a problem found in nightly or in beta, then the beta channel as well as the stable channel will get a backport. So you're not left out in the code. Let's move on to cargo. So probably many of you already know that cargo can run your binaries. It can also run your examples. So if you have a main file that is in the examples folder called whatever, you can just cargo run ---- example with the name of that file, and it will run it. By the way, if you know some of those tips already, don't fret, you're not the whole audience. Cargo has a few shortcuts to reduce your RSI. So you don't need to type cargo build or cargo test. You can just use the first letter of that. Those are built in, so you don't need to do anything to get them. Also, if you want to release a binary, then it may be a good idea in the release profile to enable stripping, which will result in smaller binaries, which is a good idea unless you plan to use the debug info for something, which is not commonly done, but yeah. If you do it, you know that you're doing it. Besides, cargo can be configured. So here is where the configuration file will be per project or per user on various systems. Of course, Windows being the odd one out. Yeah, it happens. And now let's see what we can do with it. For example, we can create more shortcuts. For example, if you don't want cargo C to run cargo check, but call Clippy instead, that's what you can do. Or you can shorten the doc open thing that will open the docs for the current project right in your browser. You can have it run example. I guess probably not many of you know the bless subcommand. It's used with compile test, which is something that we at Clippy use a lot for testing the compiler output messages if something goes wrong. So if you do some type shenanigans to ensure your safety or your user safety, then you might want to use compile test. So that might be something you may want to do. But there's more. For example, you can instruct cargo to tell rustc to use the native CPU, which means that all your CPU's bells and whistles will be used in the compiled binary. So if you have a CPU that knows AVX 512, then, well, your binary probably just got a bit faster. And, well, it's less effective on ARM and other architectures, but especially on Intel, it might give you a small speed up. Also, you can tell cargo to compile the final binary as a zero install relocatable static binary. So it will work on basically any system that has the same architecture, regardless of libc or something. And one thing that I want to suggest you use if you don't have something like a SC cache running on your system is to have a shared target folder, for cargo. Because usually cargo will put all the build artifacts into a target subfolder of your project. So if you have multiple projects, as many of us do, and those projects share dependencies, then those will be compiled for each project independently. But that means you will have build artifacts for these dependencies for each project, which leads to a lot of duplication on your disk. So yeah, having a shared target folder solves that and increases, reduces disk usage and compile time. Another thing that you can do in the cargo config is to configure which lints are used or how they are used. For example, you can set some lints to deny, which means that failing those lints is a compile failure unless there is an allow or one annotation somewhere in the code, or even set them to forbid, which means all other annotations are ignored. And you can obviously also enable some Clippy lints there if you want them, so you don't need any annotations in your code. Speaking of which, Clippy, I mean, I'm a maintainer of that project, so this is close to my heart. I want to show you a few lints that are not active by default that you may want to try. The first relate to documentation. Let's say you have such a function that is unsafe, it returns a result, and it may panic. This is just for the sake of the example. And then it will warn you if you don't have a documentation that looks like this. So you need an errors for any result returning function, you need panics for any function that could panic, and you need a safety section for unsafe function to tell your users what invariants must be upheld. There is also an unnecessary safety doc that will warn if you have such a safety section in your documents and the function isn't unsafe, because, well, probably this function was made safe somewhere and the command just stayed up, which is not something you want to do. You'll bemuse your users. And let's go on. This is an actual cargo lint, which means that it will lint the cargo toml, not the code. If you have a setup like, for example, this, where you have a crate with 2 versions, then it will warn. The thing is, if you have multiple versions of a crate, then, okay, there may be a good reason for that, but it will blow up compile time. You will compile 2 versions of that crate where you probably only need one of them, and it might be a good idea to update your dependencies. Also, in some rare cases, having 2 versions of a crate might lead to incompatible types because a type of one crate version is not defined to be compatible to a type from another version of the same crate. Then there's the non-std lazy statics lint, which has recently been added, that will warn you if you use a lazy static crate or the one-cell crate, and tell you to use the standard library types instead, which means you get to remove one dependency, which is also nice. Another thing that I see quite often with newcomers who write Rust is that they take reference to options in their functions. Just to say it here, an option of a reference is the same size as a reference. And you're not winning anything with that extra level of indirection. So the lint tells you to remove that extra reference. Then there's a lint called same name method, which will warn if you have a function that has the same name as a function from a trait that you implement, which will require the dreaded turbofish to resolve any ambiguity that will arise. Then we have the fn params excessive bools lint, which will warn you if you have a certain number of bools. Here I have only 2, so the lint wouldn't catch on by default. You can set the max number that will be acceptable. I usually try to avoid bools as function arguments unless I have only one, which is likely okay. But having an enum with 2 variants, which is basically the same as a bool, will work well and won't give your users any way to confuse them. Also, Clippy obviously has its own configuration file called clippy.toml, which may reside in your project root. And there you can set some options for Clippy. For example, the avoid breaking exported API is by default true, which is a good idea because if you have a library crate and you don't want to break your user's code in the next version, then you don't want to Clippy to suggest you do. So, but if you have a binary crate, for example, then you can set this to false to get more warnings by Clippy and improve your code even more. Then we had this The max fn param bools is the setting how many bools in function parameters you want to accept. And then there are certain Boolean options where you can allow certain lints in tests, because, yeah, test code often doesn't face the same requirements as production code. For example, you don't want to have a debug in production code, but you may want to allow it in test code to ease debugging. And you don't want the churn of having lint warnings for your test code there. So that's why you can set all of these to true. If you use them, most of them are allow by default lints, so restrictions or pedantic lints. Then one piece of tooling that is also, well, not quite recent, but a bit recent is cargo assembler checks. It will take a few seconds on your project, and you should do it whenever you cut a library release, so you can be sure that you haven't accidentally violated Semver, and your users will be happier for it. So that much with cargo tooling. Now let's go to tests. It used to be the case that doc tests were compiled to each doc test their own test binary and then executed one by one. This is no longer the case, so doc tests are really fast now, and I feel that more people should use them because they are documentation, they are tests, they also test the documentation is still up to date, so they are more than the sum of their parts. And compile-fail doc tests aren't faster, but you cannot write a compile-fail test as a unit test anyway, so if you need them, you know what you do. Also, if you have a binary crate, but you still want to write unit tests or doc tests for it, in binary crate, cargo tests will usually do nothing. What you can do here is you can write a combined binary and library crate. You just need one library section in your cargo toml and one binary section there. And then you can use within the binary file all things from the crate by just prepending crate : : and there you are. Another thing that is, in my opinion, underused is snapshot tests. Often you want to compare the result of some function with some good known value. But it's often, well, not hard, but cumbersome to come up with a value. It takes a lot of setup in the code. And so there is Insta, which is a crate that does snapshot tests. So when you first run such a test, it will see that there has been no prior invocation, so it will take that current output and store it in a file. And then you can review it via an cargo insta command. And then, wow, I haven't seen that before. There we are. And then the next time it runs, it will check the output then against the good known state that you've blessed before. So also, Insta allows to create reductions. So for example, if you have UUIDs or other random elements in your objects, then you can simply replace them with a known identifier. You can also put a function in there. I didn't want to have an example there, but I have used it in Angular and it works quite well. So you can have, I don't know, some hash map of known states to other states, or you can simply generate identifiers on the fly and then look them up in a hash map or something. Another thing that is quite underused is mutation testing, which is basically testing your tests. So what is the difference between mutation testing and test coverage? With test coverage, you can see how many of the lines of your code have been run, but you don't see if they have been tested, only that they have been executed. Mutation testing will introduce errors in your code to see if tests fail. So if such a change, which is called a mutant or a mutation, survives all tests, this might be a problem because that line of code is not tested. So as you can see here in my code, I still have some work to do. Also, I am the author of the Cargo Mutagen project, which currently still uses nightly. However, there's the Cargo Mutants project, which does similar things and runs today. So I'll advise you to use that. Also, if you still use Cargo Next Test, which on its inception was faster than Cargo Test, you can now go back to Cargo Test because Cargo Test has gotten much faster during the recent weeks. Another thing is if you use a Rust Analyzer-based IDE, which might be VS Code or Vim or Helix or some others, then you can have some settings that might improve your life there. For example, if you work with Rust C internals, then having this first line here will tell Rust Analyzer to find the Rust C source code, which will lead to better autocomplete and other things. And the prefer prelude setting means that if you import things from another crate that has a prelude, then those imports will be preferred, which is also often a nice thing to do. And if you look at references, you will often see test references. And this might be what you want, but it also might not be. So if you don't want to do that, then you can exclude those references here. Now, if you are like me and have a lot of Rust projects, then your shared target folder might look like this. Yeah, I'm already doing some things against this, so yeah. But there is a solution. You can run cargo sweep. This is a subcommand that will look through your target folder and weed out old artifacts, either those that are older than, say, 2 weeks or something, or that have been built with an older Rust version at least. So if you run Linux, such as I do, then you can simply have a cron job that every Friday looks if there is an update, and if so, run a cargo sweep to remove all old built artifacts, because you no longer need them anyway. Another thing that will help you upset your projects is Cargo Wizard, which is, as the name suggests, a wizard, basically a dialog where you can select some settings to get a good template for your cargo toml and for your project. There is also Cargo PGO, which might eke out a bit more performance. I will refer to Alexander Zeitzau's talk for more information, so I don't want to double the info here. If you want to do anything with WebAssembly, then Cargo Component is for you. So you can run your code as a WebAssembly module directly from your command line. The typical subcommands work as usual, as you expect them, and you can use any target runtime. For example, here I use wasmtime, which is written in Rust. If you use wasmtime, then you have this --dir argument, which allows you to allow file access to the current directory. So if your code doesn't need to do any file access, then you don't need that. But if you want to allow it, then that's a good thing to do. Also, if you don't want to type cargo test everything you did something, then you may want to have bacon in a sidebar terminal, which will run cargo test on each change that you save and show the output. This will be another great RSI saver. Finally, let's go to the language. You know that Rust has pattern matching, and there's a lot to it. It has actually more capabilities than many know. For example, you can match on a number or on a range, on an inclusive or exclusive range of numbers. You can match on tuples, and you can even match on slices, like here with the AB. So this will match only slices that are at least 2 elements large, and will set A and B as reference to the first 2 elements. There are also guard clauses here, like the if predicate. This is not an if in the match arm, but it's really part of the pattern. So the pattern won't match if predicate doesn't hold. You can also combine patterns with pipe symbols, even within other patterns. And one thing that many people don't know is you can also prepend a pipe symbol to your matching pattern, which means you get this nice looking syntax here. And also, if you just want a Boolean whether a thing has matched or not, the matches macro will reduce a lot of code there. Also, if you combine patterns with pipe symbol, note that if you have any bindings within those patterns, those bindings types must match, otherwise you will get an error. Also, what not all people know, that function signatures are also patterns. So you can destructure, let's say, a struct directly within your function signature. And just for the record, closures are functions too. Patterns also work in let. Obviously, you can have irrefutable patterns, such as here the tuple. If you have a 3-tuple and match on a 3-tuple, you'll get the 3-tuple unexpectedly. If you have a refutable pattern like the sum here, then you can use let else. Note that whatever is in the else path needs to diverge, so you can return, you can panic, you can break from the current loop or something, but you need to diverge from the code path, or else you cannot have any bindings, which would make the whole thing moot. You don't need a let else if you don't bind anything. And assignments are also destructuring. So you can assign multiple values using a tuple, or you can assign multiple parts of a struct by doing that. I'm missing an example here, sorry. Anyway, let's go on. The language also has annotations, which are also quite underused in a lot of code that I see. One thing is, if people work with lints, then I often see allow annotations in the code. I often do a GitHub search for that to see what Clippy lints are of questionable quality, or might have too many false positives, or might be too wordy or whatever. So I would suggest you use expect instead, because if you have an allow annotation and the lint gets fixed and it would no longer trigger, the allow annotation will stay there. So it will be there until the end of time, or if someone cleans up and finds out that, okay, this does nothing. If you use expect instead, then once the lint has been fixed, this will warn that you have an expect for something that is no longer there, so you can remove it. So you don't get to forget to remove the annotation. Another thing that you can do if you write a library to help your users is to put must-use annotations on functions that are only there for their result, so that people don't use a semicolon after them inadvertently and have a unit instead of whatever you intend to do with that function. You can also put a must-use on a type that you intend to return from functions. That is just like if you had added a must-use annotation on all functions that return that type. So less typing, more help. This is a pretty new one. The unimplemented annotation will let you deal with Rust error messages. So you can improve the error messages in case a type doesn't implement your trait. So for example, if you have a trait that can be implemented by deriving something else, then you can state so in that message, so your users won't be befuddled there. And also, if you have an inner type that implements a trait and you don't want that type to show up, then you can tell the diagnostics to not recommend it. Also, for the library, a technique I find underused is box leak for having, let's say, a configuration that you intend to put around your functions, and you don't want to care about copying it or cloning it. So if you just use a static pointer by box leak, you can pass it around your code, and you don't need to care about lifetimes. That's nice. And that's all, folks. Thank you.